In the next few scenes, you will witness a simulated burn-through event which occurred at Ontario Hydro's Research Division High Current Testing Laboratory. The apparatus used was a 3-meter-long, 6.4-mm-thick aluminum chamber enclosing a conductor simulating 230 kV conditions. The chamber was pressurized with SF6 to 150 kilopascal and arc affected to a predetermined position by means of a fine fuse wire. A diagram of the end view of the chamber illustrates the setup. 60 Hz current with a magnitude of 32 kA was fed from 2 directions to the arcing point to create the worst condition likely to be encountered during a fault. Recording instruments such as gas sampling containers, particulate size analyzers, optical sensors, and high cameras were placed at key locations inside the laboratory to collect relevant data during the experiment. Because of the potentially hazardous nature of the arcing byproducts ejected during the burn-through, the laboratory was lined with stick sheets for the protection of delicate equipment. In the control room adjacent to the laboratory, the engineers checked out the instruments and camera control circuits minutes before the initiation of the high current arc. The next few scenes are a record of the burn-through phenomena as filmed by normal and high-speed cameras strategically located in the laboratory. The pictures show how the SF6 enclosure was punctured, the ejection of the hot plasma, the spread of molten aluminum droplets, and the motion of the enclosure during the burn-through. The light from the power arc was so intense that it momentarily blanked out the 500 frames per second camera. This scene demonstrates the ejection of the hot plasma as recorded by a 3,000 frames per second camera. The end view of the arcing chamber seen through the plexiglass end plates shows the arc, which was initiated at the 3 o'clock position and swung to the 1 o'clock position and burnt through the aluminum enclosure in 5.5 cycles. The cloud generated by the chemical reaction between the arc and the metallic enclosure was so thick that it blocked off the intense light from the arc. In the high current laboratory, immediately after the burn-through, arcing byproducts consisting of foul-smelling gas and fluoride dust particles rose to the top of the building before finally settling down to ground level. The experiment has provided much valuable data on SF6 substation and indicated the procedures that should be initiated should a burn-through occur, the cleanup become necessary. The experiment portrayed represents the worst situations that could be experienced in the actual operation of an SF6 substation. The probability of a burn-through event occurring which may create this situation has been found to be extremely small. From a utility point of view, the increased understanding of SF6 technology represents a forward step in the design and construction of safe and efficient components in a power system.